Thank you. This is Sudhir. He's a senior solution architect with AWS. My name is Christian Romming. I'm the CEO of Atleap. All right, so let's get started. This is a short talk. So in order to make this hopefully useful to you guys, we're going to keep it to just 5 topics. And so, if you have issues with your data lake that are not covered in this talk, then the brevity of the talk is probably the reason. So, first of all, what do we mean by a data swamp? Well, in short, it is a situation where a lot of data is getting in, but analysis are not really getting out. This could be the result of having few analysts on your team with the requisite know-how to analyze data that's in the lake or make use of the data that's in the lake. So how do we democratize the data that's in the lake so that more analysts can use it? So let's dive right in. There are lots of names for the different zones of a data lake. And different implementations, different data lake implementations have different numbers of them as well. So what's common, though, to many lakes, most lakes that we know about, is that they have at least these 2 zones, a raw zone where new data is landing, and a curated zone where analytics-ready data is stored. Between these 2 zones, there are things like this that have to happen. So basically processes for things like structuring, right? Structuring your data, so basically turning raw data into tables and columns and rows. Cleaning, right? Applying transformation rules in order to enforce types, for example. And semantic partitioning, for which basically means put different rows in different folders so you have faster queries. So a problem with this is that typically you need engineers in order to basically make this data available to analysts. And a key concept of a data lake is that something that distinguishes the data lake from a data warehouse is schema on read, right? Which promises flexibility in terms of which parts of the data are actually used for analysis is something that you determine later. But in lots of data lake initiatives, what ends up happening is that without a strategy for how you're going to use the data down the line, the project of turning data into something that's even just explorable is such a daunting project that a lot of analysis that really ought to be done just never happen. And so this leads to our first possibly controversial, but nonetheless, a proposition that we feel is a good one is basically enabling exploration by giving all data a minimal schema. So even if this means just providing a way to map to the set of fields that are available, this can be incredibly useful because it enables analysts to take an initial look at the data by writing a SQL query, using Hive or Presto or Athena or Redshift Spectrum. And this greatly increases the audience that are able to explore the data. Now, in order to get there, you might need to do a tiny bit of engineering, and we really encourage keeping the amount of engineering you do at that stage to a minimum. So that means not focusing on performance, not focusing on data semantics, and basically not limiting the amount of data that you're actually storing in the lake. So in other words, don't do any of the things that are listed underneath that mountain there. Basically, just do just enough so that you can define an external table in your favorite schema store, and basically to enable SQL queries for exploration purposes only. So, in order to justify that engineering cost of setting up and maintaining a process for creating these minimal schemas, here's one way you can do that. Think of it as justifying the initial cost by or basically the observation is that data is read many more times than it's written, right? It's read many times, written once. So you can amortize the additional cost of this, this initial writing over all the times that it's being read down the line. OK, so now you got a, if you follow this principle, you got a minimal schema on the data, and you have, in theory, you now have SQL access to it. Now, there's obviously a lot more work that needs to be done in order to make it analytics ready. And this is where the different zones of the data lake come in. So a pattern that we see a lot is that engineers are backlogged, right? They're busy with lots of priorities, and they have a backlog of work. And another observation is that building these pipelines that are required from taking the data from left to right in this lake, right, are engineering projects, but they involve a level of encoding business rules. And these business rules are often better known by analysts than engineers. And so a result of that is that there's a lot of back and forth between engineers and analysts. And the end result of that is that not only does it take longer to get to analytics-ready data, but it affects how the analysts work. And again, it reduces the impact that analytics can have on the business. And so our second idea is to make it a focus for the data engineering team to reduce or eliminate data engineering in the process of doing data curation. If you can do that, then you end up in a much more scalable situation where you can scale both the number of sources that you're integrating and the number of analysts and analytics projects that you can handle as a data engineering team. And so what do I mean by basically creating these reusable, scalable features? Here are some examples. Event stream compaction, right? So when you're ingesting data into your lake, you want to keep your batches small so that you can get low latency in your dashboard or your interactive analysis. But you get into a really bad situation if you have millions of files in S3. I'm sure many of you are familiar with that problem. And so having a background process that compacts this data is a good idea. And you don't need to write one of those processes for every event stream that you're ingesting. You can reuse it. Another example is insert, update, delete consolidation. Right? So you have a stream of data that contains inserts, updates, and deletes to records. And you want to have snapshots, essentially, both sort of the latest snapshot of the data and also point-in-time snapshots that you can query later. And so again, you can have a generalized process for doing that. And the final one is much more high level, right? Pipeline monitoring. You want to ensure that your pipeline is live, delivering data within your SLAs and within your defined data quality standards. And the parameters, right, for those can be quite different for different analytics projects. But the process of pipeline monitoring is completely generic, right? And it's something you can reuse across projects. Now, in the ideal state, right, you build these components and they're entirely pluggable, right? So that whenever you're onboarding a new source or doing another analytics project, then it becomes more about configuration than development. And you can unleash the curiosity of your analysts much earlier on in the process without relying on data engineering. However, even if you don't really get there, right, you might only sort of get halfway there where there's still development involved. We feel like it's helpful to think of these as features, right, that your data team develops. And so this way you kind of keep your team focused on enabling analytics projects rather than working on specific analytics projects. All right, so now you've enabled exploration, right, early on in the process. And you have successfully bridged the gap between your row zone and your analytics-ready data. So what's left? Well, for one thing, you now want, or your analysts rather, want their queries to be snappy, right? And so a pattern that we see more and more is that the data lake is being used as a source for materializations of the data in the data warehouse. And so that's our idea number 3, basically enable analysts to self-serve, right, when it comes to building materialized views. And while it's arguable that data engineers should be involved with the upstream steps in this data curation process, there are almost no good reasons that we know of why engineers should be involved in this step. And so the good news here is that if you're using S3 and Glue for your data lake and Redshift for your warehouse, then with Redshift Spectrum, you get a very sort of easy to use tool for creating these materialized views. And with that, I'll turn it over to Sudhir, who will give you some ideas on how to effectively unify your data lake and your data warehouse.
Thank you, Christian. Thank you, Christian. Thank you, Christian. OK, now let me talk about the 4th value propositions. How can you unify your data warehouse with the data lake? So if you are not aware of, Amazon Redshift is a fast, fully managed cloud data warehouse database service. And with the Redshift Spectrum, now the user gets ability to query the open file format data which is sitting in the Amazon S3 data lake, and there's no need to load the data into Redshift cluster itself, which means that you can create your minimum size of Redshift cluster, but still you get the full insights on your complete data sets. So what the customers can do, keep the hot data inside the Redshift cluster and the cold data in Amazon S3, and build an external tables on top of the S3 data sets. And with the help of Redshift Spectrum, query the S3 data along with the Redshift tables as the same way you query any normal table. So that's the ability you get it with the Redshift Spectrum. And you have the full access. You can query, you can get the access the CSV, TSV, or Parquet, any kind of file format. And with the Spectrum, now you can scale your data, compute requirement and the storage requirement separately. There is really no need to create a giant cluster to ingest your petabytes of data inside your data warehouse database. There are some design principles to design a high-performance data lake. The first thing is always partitions your data based on the query filter, because so that it can leverage the partition pruning to reduce the amount of scan to return the results faster from your data lake. The second thing is we recommend use the compression for your data file so that you can minimize the number of IOs, and at the same time we recommend use the columnar file format as much as possible, because the column, like the Parquet, because it provides a better compression as well as it is a more efficient for the modern analytics engines like the Amazon Redshift or Athena or even the Presto. It works really great. The third recommendation is compact your data set so that you can reduce the million number of files into the less number of files to reduce the unnecessary, the scanning more number of files. So we highly recommend schedule some compaction jobs on the schedule basis to get the data for your data warehouse. Now the 5th proposition is setting up the security primitives for your data lake and the data warehouse. The security is always #1 priority for AWS, and we provide n number of security controls to meet the security objectives for your enterprise. So here are some security examples which you can use to protect the data in Amazon S3. Like you can use server-side encryption, SSE S3 or SSE KMS, or even you can use the customer managed key to encrypt the data at the server side. At the same time, you can also use the client-side encryptions to encrypt your data sets in Amazon S3. S3 also supports the SSL endpoints, which you can use it to achieve the encryption in transit. We also provide some of the capabilities like the IAM control, integration with the IAM users and IAM roles, as well as the bucket policies and ACL controls. So you can protect your data which is sitting in Amazon S3. You can grant the specific access to the specific user group in order to protect your data. And in case if you have the compliance requirement for the auditing and logging, yes, you can turn on the access logs for your S3 bucket, so that whatever the request you are making to the S3, it is being recorded into the form of log. We also provide the CloudTrail service, so that any API calls which you are making to the Access S3 or even the Redshift or your data lake, it is being captured, which you can use it. The next is the security controls for your Redshift cluster. So Redshift, the good thing about Redshift is security comes at no extra cost. Normally, for any other, in general, any data warehouse or database, when you want to turn on some security features, you have to pay some extra licensing cost. But with Redshift, it is not the case. Redshift provides end-to-end encryptions, including the encryption in transit, encryption at rest, as well as it fully integrate with IAM, so that you can have the right kind of controls, who can create cluster, who can modify cluster, even who can query the data which is stored in Amazon S3 as well as in the data lake. Similar to any other database, we also provide the database security models, like you can create the users, groups, and the permissions to manage the permissions for your data warehouse. And Redshift is fully certified for the SOC 1, 2, 3, even the PCI, HIPAA, and more certifications. Now, I want to pass back to the Christian.
Thanks, Sudhir. So in summary, here's some ideas for how to build better data lakes, and hopefully some of these are useful and actionable for you if you already have a process for ETL set up. At Leap is at Leap, we're building software to reduce the amount of engineering effort it takes to build data lakes and warehouses on AWS. And we also focus on reducing the time to value for new data sources. So it's ETL as a service, and it helps you integrate data from all of these data sources, many more, these types of data sources, I should say. And it also encapsulates a lot of the ideas that we've talked about today. So that's it. Thank you for listening. We are right over there, so if you want to come and talk to us, we'd be happy to talk to you. Thank you.